Again, warm-up number 49, compute the measure central tendency and sketch a box plot. A statistics student has the following pop party scores in percent for his current progress report: 100, 75, 100, 90, 85, 0, 60, and 95. Since this is a word problem and they're asking us for data, bring over your conclusion that you wrote down. What conclusion did you write down? All right. Pick someone, Areli. Conclusion. Who? Fernando, conclusion. The average scores are between what? 60% and 80%. Hands if you agree with that. So you get that from your box plot? Okay. Hands if you agree with that. Okay. Some of you. 10Q. I'll take that. All right. Copy the agenda, please. Warm-up number 49, measures of variation. Act like tomatoes. Even though I did leave lesson plans for the sub. Today was supposed to be a day that I didn't leave you any home play. But let's see how the lesson goes. If we get it, then we're done. If not, I might leave you some practice, but I think we got it. It's fairly straightforward. So once again, warm-up number 49, measures of variation. Today we finalize this portion, and then we act like tomatoes. So there's no code for today, just giving you the presentation. All right, I can summarize data and compute the measures of variation. So we've been on this for a while already. We know that measures of variation of range, standard deviation, and variance. And we know that we covered already central tendency, we covered variation, and we're headed towards position. That's where we're starting next week. But I didn't want to get started this week because we have a 4-day week. Tomorrow is our last day of the week, and I just want to make sure that we end our week well before we get started with position next week. However, let me revisit normal distribution. Look up to the screen. We've been talking about bell curves, yes? Yes, Mr. Q. And I remember on the second week of school, I gave you guys all the parts of the bell curve from mu, that stands for what, everyone? Mu stands for what? Mu stands for mean, yes? And then these are standard deviations from the mean, 1 up, 2 up, 3 up, or below the mean. And we said that the normal range is in between the one standard deviation, which was how much percent? 68.26. You already have these notes, so you don't need them. However, second standard deviation, all those percents add up to 95.44. And so on and so forth. And between 3 standard deviations, it's 99.72. However, there was a mathematician that said, I beg to differ, and his name was Chebyshev. And his distribution is known as Chebyshev distribution. So write this title on your paper, Chebyshev distribution. All right, here we go. So what did he believe? Well, he believed that, yes, we do have some sort of distribution for the variation. However, he said that when you start with your distribution for your data, yes, you do need a mean. The curve, it doesn't matter the form it has. Let me repeat that again. The curve doesn't matter what? The form. We were focusing on bell curves, but he said it doesn't matter. So I'm going to start here, and I'm going to end over here. And I want you to sketch me a something distribution here. Doesn't have to be a bell curve. It could be a scribble curve, or whatever you want to call it. So sketch me a Chebyshev distribution. Once again, the form doesn't matter. We have a beginning, we have an end, and we have mu in the center. All right, so here's mine. There it is. It's all warped because he said it doesn't matter. Okay? What matters, he said, is the distribution that you give it. So we know that we have here and here one standard distribution, or one standard deviation, sorry. One standard deviation. It's kind of crooked. Let me fix this. Then we have two standard deviation. And then 3 standard deviation. You're like, it looks exactly the same, Mr. Q, except for the figure. Okay, the only thing that differs from his method to the normal distribution is that, look up to the screen, that he did not believe in regards to normal range being between the first standard deviation. He thought that the normal range was between 2 standard deviations. Not only that, he said in the second standard deviation, that totals of 75%. Write that down. His normal range is between the second standard deviation of 75%. And then he said that the third standard deviation, the total should be 88.9%, or 88.89%. And you're like, how did it come up with that, Mr. Q? Well, let me show you. He said, look up to the screen, that if you take this theorem, which is 1 minus 1 over k squared, and k has to be greater than 1, also k is the number of standard deviation. Let's see if it makes sense. So why does it have to be greater than 1? Because if you substitute 1 here, what is 1 squared, everyone? What is 1 over 1? So then we end up with a 0. So it cannot be, that's why he doesn't believe in the first standard deviation. He doesn't believe in that. He believes starting from the what? Second standard deviation. So that means number 2. Number 2. So let me show you where he got the 75. Here it goes. 1 minus 1 over, instead of k, I'm going to use what standard deviation he used? The second, right, for the normal. So I'm going to write 2 right there. So therefore, this is 1 minus, what is 1 over 2 squared? That's 1/4. So what is 1 minus 1/4? 3/4, or 0.75, or in percent is what? 75%. So let's use the same theorem again. 1 minus 1 over k squared, but now to make sure that we got the 88.9%. So before I continue, so you never what we substitute for k now. What do we substitute for k? What do we substitute for k, Jaden? 3, that is correct, because it says here k is the number of standard deviation. So we are in the third one right now. So this becomes 1 minus 1 over 9, which is 8 over 9. Let's see, calculators calculate. What is 8 divided by 9? What is it? Okay. Where did I get 8 from? So look up, guys. I made this 1 into 9 over 9 minus 1 over 9. So therefore, 9 ninths minus 1 ninth is what? Yeah, but I'm saying 8 ninths, right? So it's, you said 0.88, and that gives us what? That. From 1 to 5, I'll come to where are you with that? Yeah, we got it, right? 5 fourths, 5 fourths, okay. So what am I implying, Mr. Q? What are you implying, Mr. Q? That we need a new formula in our formulas. Let's go. So go back to your formula list and write that formula in there, and make sure you label it Chebyshev's distribution or Chebyshev's theorem. All right, I'll give you some time to copy that. All right, so Chebyshev's theorem says 1 minus 1 over k squared, where k has to be greater than 1. Once again, remind your neighbor what k stands for. What does k stand for? Yeah, the number of variation, yes? And we start from, usually from number 2. All right, so here are our updated formulas: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Let's go. We're getting there, yeah? Huh, Caleb? Let's go. All right. So, let's get started. Example Q. Write that down. Example Q. You don't need to copy the verbiage, but we're going to start with the work. It says, Mr. Q statistics formula pop parte, you're like, oh snap, had a mean score of 85 and a standard deviation of 4.5. Identify the range of the grades between which at least 75% of the students scored. So, whenever you get to these kind of problems, they want to know between where and where did students score given this information. So over here on the slide, write example Q, and you're going to start with mu. For right now, we're going to use that. Standard deviation, percent, and K. So tell your neighbor what numbers are you going to fill in for those. Talk about your neighbor. What numbers do we fill in for that for right now? All right. Get us started, Joel. Mean. Standard deviation. Percent, everyone. All right, and here's the doozy right here. According to Chebyshev, 75% of the grades fall between what standard deviation? Tell your neighbor. Everyone. Yeah, you write 2 right there. All right, so let's see between what scores that falls between. All right, so we got our mean. We got our second standard deviation. And we said how much percent was that? So the question is, identify the range of the grades between which 75% of the students scored. So this is 2 standard deviations, is that correct? So here we go. Where do we start? We start at the mean. The mean is what? 85. So where would we be at the first standard deviation? Tell your neighbor, where would we be at the first standard deviation? 80.5 and 89.5. Okay. However, we don't want those. We want what percent? 75. That means we need to go 1 more standard deviation. So where would we start over here, guys? 76. How about it this way? 94? Therefore, let's write a conclusion. Identify the range of the grades between which at least 75% of the students scored. The students scored between 76 to 94%. 10Q. Ooh-wee. You're like, that's it? That's it. Pretty straightforward, yes? So what is the one thing that we need to know and keep in mind using Chebyshev? That K is going to be whatever percent they give us in order to find our standard deviation. What if this was 88.9? Tell your neighbor what to fill in here. All right, good. Good conversations. Send me your notes. Hold on. All right, so let's see how you do with one by yourself. Example Super Q on the screen over there. It says, Mr. Q's Algebra 2 transformations pop parte had an average score of 80 with a standard deviation of 3.2. Identify the range of the grades between which at least 88.89% of the students scored. All right, once again, you don't have to copy the verbiage. Just write example Super Q and start with your 4 values and show me the graph. Make sure you write your conclusion. Go. All right, conclusion. David, go. The students scored between 70.4% and what? 89.6%. Hands if you got that. Looks about right. All right, from 1 to 5, I'll confer you with that. Pretty straightforward. All right, except when we get to this one. Example 2Q. On your paper, write example 2Q. And of course, we're going to write our values here. Mean, standard deviation, percent, and K. I'll give you some time for that. So, what information do they give us? What is the mean? The mean is 0.25. What else do they give us? Standard deviation of 0.02. Do they give us a percent? No. Do they give us the number of deviations to get that percent? No. So you're like, oh snap. Okay. So, let's draw a line. So let's see, what do they give us? They give us the mean, which is 0.25. But in this case, they give us the actual end numbers. What were the end numbers? Between what? Fall between 0.20, 0.20, and 0.30. These are the end values. So what does that mean, Mr. Q? Well, that means that we need to find the percent for those end values. Whereas before, on the previous example, didn't we start with the percent first? They gave us, they gave us the percent here, and that's how we found our end values. So, here we go. How do we find those percents? Well, we need to know how many deviations they are away from each other. So let me center this because this looks a little bit off. There it is. Okay. So, first things first, we need to find this distance. What's the distance from 0.25 to 0.30, everyone? 0.05. That is correct. Is that the same distance to this side? Let's see. Between 0.20 to 0.25, it's the same distance, isn't it? Yes. However, do we know what standard deviation we fall on there? No. But do we know what the standard deviation was? Yes, the standard deviation was 0.02. So that's going to give us 0.02. This fraction is going to give us the number of standard deviation. So, calculators calculate what's 0.05 divided by 0.02. 2.5 is our K. So let's write our K over here, 2.5. 2.5. So far so good, yes? Now going back to the beginning of the session, how did Chebyshev get that percent? By using this theorem, right? 1 minus 1 over K squared. Do we know what K is right now? Everyone? 2.5, so we're going to write 1 minus 1 over 2.5 squared. So this is 1 minus 1 over, what is 2.5 squared? 6 point something? 6.25? All right. So what is 1 minus 1 over 6.25, guys? Calculators. 0.84. And what is that in percent, everyone? 84%. So what would be our conclusion? It says here, the standard deviation of Chebyshev's theorem, find the minimum percent of the data values that will fall between 0.20 and 0.30. Therefore, data values between 0.20 and 0.30 are 84%. 10Q. So, what did we start with here? They only gave us two values, the mu and the standard deviation. We created our line, we wrote our mu. We didn't use standard deviation, but they gave us the end values of 0.20 and 0.30. And they wanted us to compute the percent. Since we didn't know where the end values were in regards to standard deviation, which standard deviation, so we took the distance from the mean to one of the values and make sure that that was the same distance to the other one and divided it by the number of standard deviation. By the standard deviation, which was 0.20. And that gave us the number of standard deviations. So check this out. So here's one standard deviation, here's two standard deviations, which means the third one is somewhere over here, because we fall in between those two. Is that correct? At 2.5? Yeah. All right. So I'm going to give you one for you to do like this. You don't have to send me your notes just to save time. Do this next one by yourself, very similar to this one, and let's see how you do. Example 2 super Q. Copy, well, you don't have to copy this, just get your data. Let's see, do they give us a mean? Tell your neighbor what the mean is, please. 12, yes. Standard deviation, 3. We need a percent, and we need the K. Do they give us the end values? 4 and 20. And we want to find that percent. All right, go. All right, let's see. Help me out. Briseda, what'd you do first? Solve for K, okay. So 12. So you got from here to here, which was what? 8, which is the same from here to here. So we got 8, and you divided that by what? By 3, which was our standard deviation. And what'd you get? 2.67. Some of you did 6.6. Hands, have you got that? Yes? All right. All right, pass someone. Illy, what'd you do next? Squared. And that gave us 1 minus 1 over 6.76. Yeah? Which gave us what decimal? 0.80 what? 85? Hands if you got 85%. Conclusion. David. The data values range between 4 and 20 is 85%. 10 cubed. Hands if you got that? That is correct. And this comes to a conclusion for measures of variation. Let's go. Because we're about to get into measures of position. Yes? All right, you can go ahead and log out. I'll stop the video right here. Once again, make sure some of you need to act like tomatoes. Grading period ends tomorrow, so make sure you're catching up. Catch up. All right. All right, those of you who are following on YouTube, make sure you find some of these problems, do some practice. Later. Bye.